Hello everyone, welcome back in Vidyaraman classes, the YouTube channel of Vidyaraman classes. So we have done previously some videos regarding previous year questions or sample paper questions of 12th classes. But before that, I think apart from that, simultaneously we should start with the different topics also of the chemistry. And for a start, as I'm starting the means of as we are building the concept of chemistry, so we have to start with base. So base is first of all, what I want to introduce here is that before starting on with any topic like solution, electrochemistry, and who are in class 12th, for them these topics, and for 11th class students, equilibrium, and every topic means first chapter, in fact some basic concept of chemistry, all we have a common a term that is called mole. In physical chemistry, a term mole is very common, and in fact not only in physical chemistry, when we talk about mains and advanced exams, this mole term can be in some or other way can be introduced in organic or inorganic questions also. So first, this mole is like a means ABCD for the chemistry. Okay, so how will you answer that? What is a mole? If I ask, what is mole? So in this video, we are just going to trying to start or trying to answer this question. What is actually mole? We have a definition that it is the number of particles as much as in 12 gram of number of particle as much in 12 gram of carbon 12 isotope. For detailed definition, you should refer your book, but I am focusing on the main definition we all have in our book. But the main thing is that we have to understand, we have to grasp that what this mole term actually means. So first of all, I will make clear that why I have asked it for C12 isotope, because carbon in our environment is occurring in two isotopes, that is carbon 12 and carbon 14. So we have to specifically when we are talking about mole, we have to specify the carbon 12 isotope. We are not dealing with the carbon 14 isotope. So apart from that, one more thing, that means 12 gram of carbon 12 isotope. Suppose I will say that how many entities are in 1 dozen, means how many bananas are there in 1 dozen. So it will be 12. If I say I have 1 dozen pen, how it will be again 12 pen, right? 12 bananas, 12 pens. Similarly, any entity or anything that are in that I specify as 1 dozen will contain 12 entity, right? Similarly, whenever I say that it is 1 mole, so 1 mole simply refers to a number that is called 6.022 into 10 to the power 23, and that is called Avogadro number. This number is representing Avogadro number, and that is denoted by Na. Now the thing is that this is not, it is not like this much only, right? So the thing is that suppose I am asking for you that 1 mole nitrogen is containing how many nitrogen atoms? Means I am saying you that I will give you 1 mole nitrogen, how many number of nitrogen atom will be there? Okay, so how many number of nitrogen atoms will be there? That will be 6.022 into 10 to the power 23 atoms of nitrogen. Similarly, now if I say that I will give you 1 mole oxygen atom, how many atoms of oxygen will be there? That will be again 6.022 into 10 to the power 23 atoms. This is quite simple, right? But now the thing is that I was talking here about only the atoms. Means I am not talking about N2, O2, CO2 and whatever. So one more thing, that 1 mole nitrogen is containing this much atoms of nitrogen. But now the question arises that how will I weigh? Means what is the relation of number of this much nitrogen atom with the mass of nitrogen atom. So if I will give you this much atoms of nitrogen, okay, and that will always be 14u. So take it as like this, that suppose there are few red balls or few small balls, right, few marbles. Okay, we will take few marbles. So I will weigh that. I will say that each marble is representing, each marble, small marble is representing a nitrogen atom. Now I gave you 14 gram, or say in term of nitrogen we are say 14u. I will give you that now mass, unit of mass is u, 14u of these balls. I have not told you the number of nitrogen atom. I have given you simply 14u. I mean 14 gram. Take it for now. Take it as 14 gram. I am giving you 14 gram of that balls. You don't know number of the balls. Just you know that the weight of this ball means the amount of that ball weighing is 14. So how many number of balls will be there if that nitrogen, it is a ball of nitrogen. So 14 gram of these balls will always contain any number of nitrogen atom. But now if I talk about suppose this is red ball. Now I am giving you a yellow ball of same size, and I am giving you telling you that is oxygen atom. Now I will give you 16 gram of these balls. That will contain how many oxygen atom? Any number of oxygen atom. So basically what is the point, that every time 1 mole will contain number that is 6.022 into 10 to the power 23 atoms, and that will contain the mass of atomic mass. If that is the nitrogen, then atomic mass of nitrogen will contain this much number of atoms. If that is oxygen, oxygen means 16 gram of 16u of oxygen will contain this much number of atoms of oxygen. That was about atoms. Now what if I talk about molecules? What if I talk about molecules? Then see, molecules, suppose I am taking about CO2. I am talking about CO2. So in case of atom we were talking about atomic mass. So now in case of molecules we will talk about molecular mass. For example, CO2 here is, CO2 has 44u. CO2 has 44u molecular mass. Now 44u of CO2, if I am giving you some large balls, that I am saying that one ball is representing CO2 molecule, then I am giving you 44 gram of that balls. So how many number of balls will be there? That will contain again 6.022 into 10 to the power 23 molecules of CO2. Now it is not about atoms, it is about molecule. When it is a molecule, that will contain this much molecule of CO2. Okay. If I am saying that I have NO2, NO2 has mass of 14 plus 16 to 32. That is 14 plus 32, it will be 46. 46u molecular mass. Then how much number of NO2 molecules? Means again 6.022 into 10 to the power 23 molecules of NO2 will be there. Okay, so now this is the point, that whenever we are talking about a molecule, that it's a mass equal to that molecular mass. Means that if I am talking about a molecule, again I am repeating, if I am talking about a molecule, mass equals to its molecular mass will contain Avogadro number of molecules. If I am talking about atom, its mass equals to its atomic mass will contain number of atoms equals to Avogadro number. Okay, similarly ionic compound, ions also, if I am talking about a ion, equals to mass equals to its ionic mass or formula mass, it will contain same number of, is Avogadro number of ions. That is all about the mass relation and number of atoms or number of molecules. Now I will tell you about how to calculate number of moles. I hope that you are all clear. Okay, for knowledge I will tell you one more thing, that whenever we are talking about a gas, means suppose I am talking about whatever you gas you can take, CO2 again, take it as CO2 gas, always 22.4 liter. If I am talking about CO2 gas, 22.4 liter at STP. STP is standard temperature and pressure. Pressure will be 1 atm. So again temperature will be 273 Kelvin and pressure is 1 atmosphere. Whenever the condition is this at STP, means temperature is 273 Kelvin and pressure is 1 atmosphere, then always 22.4 liter of that gas will contain Na number of molecules. Means it is equals to 1 mole. Okay, I hope I am clear. If any gas at STP is taken, that is temperature condition is 273 Kelvin and pressure is 1 atmosphere, then always 22.4 liter of that gas will contain 1 mole. Okay, so this is the term when we are talking about gas. So now this was all about how to relate number of molecules, number of atoms with at the condition of STP, or say at the means mass equals to molecular mass or atomic mass. Now the thing is that suppose I will give you a question. Okay, now suppose I am giving you 88 gram of CO2. Okay, and I will ask how many moles are there. Now I will tell you how that famous formula of the number of mole came. 88 gram of CO2 is there. How many moles of CO2 are there? Now if I say 44 gram of CO2 is containing how many moles? 1 mole, right? So now 88 gram of CO2 will contain 1 by 44 into 88. This is actually what? Unitary method. Okay, unitary method is when this is 44 gram is containing 1 mole. So 1 gram will contain how much? 1 upon 44, and 88 will contain 1 by 44 into 88. So this is the unitary method. If you are clear with unitary method, it will be more interesting for you, and if not, then you can simply stick to the formula also. So 88 gram is containing this much, 44, 2 mole of CO2 are there. Okay, now the thing is that simply formula is derived number of mole equals to given weight. Given weight is in how much weight I have been asked the question. In question means how much weight is mentioned. So number of mole equals to become given weight by, given weight is 88, by molecular weight. And this is simply, sometime different terms are used for these type of things. Given weights can be termed as small w, and molecular weight can be termed as gram molecular weight. So these are the different notations. First, the thing is that number of mole is equals to given weight by molecular weight. This is the formula. Now an interesting part comes that when I asked that 1 mole of CO2 is having 44 gram mass, it was all fine. Number of mole came 2 mole. So now 2 mole CO2 is there. What if I ask how many number of carbon atoms or oxygen atoms are there, or how many moles of carbon or how many moles of oxygen are there? So see, 1 mole of CO2 means, again, if 1 mole of CO2 is having how many carbons? 1 atom of carbon and 2 atom of oxygen, right? One more thing, that 2 mole CO2 can be also written as 2 into Avogadro number of CO2 molecules. Am I right? 2 into Avogadro number of CO2 molecules, because 1 mole contains Na, so 2 mole will contain 2 Na. Na here represents again 6.022 into 10 to the power 23. So now 1 mole of CO2 is containing 1 atom of carbon and 2 atom of oxygen. So it means that if 2 mole I am talking about, it will contain 2 atom of carbon and 4 atom of oxygen, right? So now, or you can, one more thing you can add it here is that 1 mole of CO2 is containing Okay, fine. One thing I have to correct here. One mole of CO2 molecule and 2 mole of CO2 molecule again is containing one mole of carbon atom and 2 mole of carbon atom. It is also mole, but these moles are of atom, not for molecules. Again I will explain. 1 mole of CO2 is a molecule, we already know that, right? 1 mole of CO2 molecule is containing 1 mole of carbon atom, because in CO2 if it is 1 mole then only 1 carbon is there. So 1 mole of carbon atom, 2 mole of oxygen atom. So if they ask me how many oxygen atoms are there, now if they ask how many oxygen atoms are there, then what I will write, if that is 4 mole, so 1 mole is containing what? Avogadro number, right? So 4 into Na oxygen atoms are there. Am I clear? So now we will do one question, then we will be clear that what we are discussing here. So now here is the question. 51 gram of NH3 is taken in a flask. Calculate number of moles of NH3 molecules, number of hydrogen atoms in 51 gram of NH3, number of atoms of nitrogen in 51 gram. I have written question by myself, so if any inconvenience in calculation, so just pardon. So now listen. First question is number of moles of NH3 molecule. So we can go by formula also. Simply the formula will be number of moles equals to given weight is 51 and molar weight is 14 plus 3 17, and 17 into 3 mole it will be given. Okay, and if you go by unitary method it will be also same. 17 gram is containing 1 mole, then 51 gram will contain 51 by 17, that is 3 mole. Okay, now B part. Number of hydrogen atoms in 51 gram of NH3. If 51 gram of NH3 is containing 3 moles, it means 3 mole NH3. See, first of all, 1 mole NH3 contains 3 mole hydrogen atoms, right? 1 mole NH3 molecule contains 3 mole hydrogen atoms, and 3 mole hydrogen atoms means 3 into 6.022 into 10 to the power 23 hydrogen atoms, because here I will write, because 1 mole is containing 6.022 into 10 to the power 23 hydrogen atom. Simply 3 mole will become 3 into 6.022 into 10 to the power 23. Okay, here we got that. Now next is number of atoms of nitrogen. So similarly it will become, so it is about 1 mole NH3. Okay, sorry, 1 mole NH3 is containing this number of hydrogen atom. So what about 3 mole NH3? 3 mole NH3 will be 3 into 6.022 into 10 to the power 23 hydrogen atoms. Okay, similarly 1 mole NH3 is containing, if 1 mole NH3 is containing, if 1 mole NH3 is containing 1 mole nitrogen atom, then 3 mole NH3 will contain 3 mole nitrogen atom, and that is equals to 3 into 6.022 into 10 to the power 23 hydrogen atom. So now this is all about number of moles and what is mole. So if you really want to go like in deep concepts of chemistry and deep terminologies, see, according to me, you have heard the line that chemistry has so many exceptions. I will not deny that, but I believe that in progress of doing that graduation and then post graduation in my subject in chemistry, I got to know one thing, that no, every exception can be explained by some or other logic. If you can, means if you want, you can explain every exception by a logic. Every exception has a reason. Okay, 1% are really exceptions, but still 99% of the time, every exception we tell our student that this is the exception, this is the exception, this is the exception. Every exception has a logic actually, but the thing is that these exceptions are means maybe due to some or other reasons, students are told these things. But I believe firmly that every exception can be explained if we want, and I will try my best for this thing only. So I'm on the path to prove that okay, chemistry is not like just for cramming, apart from some topics. So in this process or in this journey, just support us, help us, and subscribe the YouTube channel. And if you want, you can join us offline also. My contact number, you can ask me in comment, or I will see that I can provide it by other means also. Okay, thank you so much. Have a nice day.